Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for February-March 2017. So let's get started. Question 1 says the diagram shows the height of a stack of identical coins. What is the thickness of one coin? So we have here 12 coins and the total distance is 2.40 centimeters. So we divide 2.40 by the number of coins 12. That gives us the thickness of one coin 0.2 centimeters. So we have 0.2 but the unit is wrong. It is millimeters, not centimeters. To convert from centimeter to millimeter, we multiply by 10. So 0.2 will become 2 millimeters. So the answer is B. Question 2 says 4 balls with different masses are dropped from the heights shown. Air resistance may be ignored. Which statement about the balls is correct? Ball P has the greatest acceleration. No. When moving under gravity with no air resistance, they all have the same acceleration, even if the mass is different. So not greatest. Balls Q and R take the same time to fall to the ground. No, same acceleration but different distance. That will take different time. The acceleration of ball R is half the acceleration of ball P. No, again, all have the same acceleration. D says ball S has the greatest average speed. Yes, because we have the average speed calculated as the total distance over total time, and also when moving with constant acceleration, it is equal to the average of the initial and final velocities, and the initial velocity was 0, so the one with the greatest final velocity will have the greatest average velocity. And to reach a large velocity, we need to fall a very long distance. So the last one will have the greatest distance and the greatest final velocity, so greatest average velocity. So we choose D. Question 3 says an object is traveling in a straight line. The diagram is a speed time graph for the object. At which labeled point is the object accelerating at a changing rate? So we need a changing acceleration, means that there is no straight line, so we don't choose any straight line. So we choose B, which is a curve. Question 4 says which statement about the masses and weights of objects on the Earth is correct? A balance can only be used to compare weights, not masses. No, it can be used. Heavy objects always have more mass than light ones. Yes. Large objects always have more mass than small ones. Not necessarily if the density is different. Mass is a force. No, weight is a force. So the answer here is B. Question 5 says an object in a space probe above the Earth weighs 3.5 newtons. The gravitational field strength at the height of the space probe is 7.0 newtons per kilogram. The gravitational field strength on the Earth's surface is 10 newtons per kilogram. What are the mass and weight of the object on the Earth's surface? So first we calculate the mass by dividing the weight by the gravity field strength. So we divide 3.5 by 7.0. That gives us a mass of 0.5 kilograms. So we have here A or B. And for the weight, we calculate the mass multiplied by the gravity field strength mentioned above. So we multiply 0.5 times 10. That gives an answer of 5 newtons. So the answer here is B. Question 6 says a skydiver jumps from a stationary helicopter and reaches a steady vertical speed. She then opens her parachute. Which statement about the falling skydiver is correct? As her parachute opens, her acceleration is upwards. Yes, because air resistance upwards is now greater than the weight downwards. So there is a resultant force upwards and acceleration upwards against her motion. As she falls at steady speed with her parachute open, her weight is 0. No, the weight is not 0. When she accelerates, the resultant force on her is 0. No, if there is an acceleration, there must be a resultant force. So wrong. When she falls at steady speed, air resistance is 0. No, again, because the air resistance must balance the weight. So the answer here is A. Question 7 says a car moves in a circular path as it turns a corner on a horizontal road. The car moves at constant speed. Which description of the forces acting on the car is correct? All forces are balanced as the car is moving at constant speed. No, because it is changing direction. So velocity is changing, so there must be a resultant force. The forces are unbalanced, unbalanced, yes, and the resultant force acts away from the center. No, it acts towards the center of the circle and not in the direction of travel of the car. So the answer here is C. Question 8 says a moving body undergoes a change of momentum. What is the unit for the change of momentum? It is Newton second or kilograms meter per second. So we choose C. Question 9 says a man can either take an escalator or a lift to travel up between two floors in a hotel. The escalator takes 20 seconds to carry the man between the two floors. The useful work done against gravity is W. The useful power developed is P. The lift takes 30 seconds to carry the same man between the same two floors. So we have the same distance and the same force, which is equal to the weight of the man. How much useful work against gravity is done by the lift and how much useful power developed by the lift? It is in comparison to W and P done by the escalator. So we're moving the same distance with the same force, so the same work. It is the same W. And in the lift, the time was longer, so the power is actually less than the original power. So here the answer is C. Question 10 says a 40-watt lamp wastes 34 joules of energy every second by heating its surroundings. What is the efficiency of the lamp? So the efficiency is equal to the useful output over the total input. So the useful output is actually the difference between the input and the wasted energy, and then we divide by the input and then multiply by 100 to get a percentage. That will give an answer of 15%, so we choose B. Question 11 says a column of liquid has height h, mass m, and density rho. The gravitation field strength is g. Which expression gives the pressure due to the column of liquid? So the pressure due to a liquid is equal to rho gh. So we choose D. Question 12 is about barometers, so you can skip this question for the new syllabus. It says the diagrams show two mercury barometers. The right-hand diagram shows a tube of larger diameter. There is a vacuum above the mercury in both tubes. Which labeled position on the right-hand tube shows the mercury level in the right-hand tube? So if they are in the same room, there is the same atmospheric pressure, and the diameter does not affect the height of the liquid, so we choose the same height. So the answer is B. Question 13 says very small pollen grains are suspended in water. A bright light shines from the side. When looked at through a microscope, small specks of light are seen to be moving in a random jerky manner. What are the moving specks of light? They are the pollen grains, not the water molecules. They cannot be seen by this type of microscope. Being hit by other pollen grains, no. Being hit by water molecules, yes. So we choose B. Question 14 says at negative 39 degrees Celsius, liquid mercury solidifies without a change of temperature. Which row shows whether the mercury absorbs or releases energy and what happens to the bonds between the mercury atoms? So for solidification, the energy is released, not absorbed. And for the bonds going from liquid to solid, we become stronger. So the common choice here is C. Question 15 is about thermometers, so you can skip this question for the new syllabus. It says a model thermometer consists of a flask of colored water and a stopper with a glass tube passing through it, as shown. The model thermometer can be changed in one of two ways. The flask can be replaced with a larger one full of colored water. The glass tube can be replaced with one with a larger internal diameter. Which statement is correct? Only using a larger flask increases the sensitivity. Yes. Only using wider tube increases sensitivity. No, it decreases the sensitivity. Using larger flask increases sensitivity. Using wider tube increases sensitivity. Again, wrong. Neither using larger flask nor using wider tube works. No, because the wider flask or the larger flask will work. So the answer here is A. Question 16 says a metal has a specific heat capacity of 360 joules per kilogram degrees Celsius. An object made of this metal has a mass of 2 kilograms. What is the thermal capacity of the object? So we have two equations. Energy is equal to the mass multiplied by the specific heat capacity by the change in temperature, and the energy is equal to the thermal capacity, not the specific thermal capacity, by the change in temperature. So here the only different thing is we have thermal capacity and mass times specific heat capacity, and all other variables are the same. So we can say that the thermal capacity is equal to the mass multiplied by the specific thermal capacity. So we multiply the 2 kilograms by the specific heat capacity, 360 joules per kilogram. So we are making sure we have the same unit. That would give an answer of 720 joules per degree Celsius. So we choose C. Question 17 says, in which type of substance are free electrons involved in the transfer of thermal energy? All liquids, no. All solids, no. Metals only, yes, because they have free electrons. Plastic only, no, because it doesn't have free electrons. So we choose C. Question 18 says, for objects made of the same material and have the same mass, are at the same temperature, the objects have different surfaces and different surface areas. Which object emits infrared radiation at the greatest rate? So the best emitter would be a dull surface and with a large surface area. So the common choice is A. Question 19 says a person uses a surfboard to ride every 30th wave crest towards a beach. The wave crest travels at a speed of 1.6 meters per second, and the distance between each wave crest is 24 meters. That's the wavelength. How many wave crests does a person surf in 1 hour? So we can first calculate the frequency. Frequency is equal to the speed divided by the wavelength. We have 1.6 over 24. And this is for 1 second. This is the number of waves in 1 second. To get the number of waves in 1 hour, we multiply then by 60 minutes and then 60 seconds. That will give us 240 waves in 1 hour. But we are not riding all the waves. We are riding every 30 waves. So then we divide 240 by 30. That will give us 8 waves. Question 20 says, in a shallow tank, a water wave moves towards a barrier with a narrow gap. Which diagram shows the wave beyond the barrier? So the gap in the barrier is almost the same size as the wavelength. So there will be a curved diffraction with large spreading. So curved, it is C or D, with large spreading, that is D. Question 21 says, light passes along an optical fiber. What happens to the light within the fiber? It is total internal reflection. So we choose D. Question 22 says the points labeled F are the principal foci of a lens. A beam of parallel light is incident on the lens. Which diagram shows the path of the light after it passes through the lens? So this parallel beam is parallel to the principal axis. So from the other side of the lens, it should pass through the focal point. So here is not passing through the focal point. Here it is passing through the focal point. And for C and D, they are not passing through the focal point either. So the choice here is B. Question 23 says, which statement about sound waves is correct? They are able to travel through vacuum. No. They are able to travel through solids. Yes. They are transverse waves. No. They are longitudinal. They travel at the same speed in all substances. No. They travel fastest in solids and slowest in gases. So the answer here is B. Question 24 says, which statement about ultrasound is correct? It is produced by a rapidly vibrating source. Yes. The frequency is higher than 20,000 Hertz. It is uncomfortable to human ears. No, because they are not heard. They are not detected by human ears, so they will not be uncomfortable. Its frequency must be greater than 300,000 Hertz. No, 20,000 Hertz. It travels the fastest in vacuum. No, they cannot travel through vacuum as all sound waves. So the answer here is A. Question 25 says a small compass is placed close to a strong bar magnet, the same distance from each end. Which diagram shows the direction in which the compass needle points? So first we need to draw a hypothetical field line, and the compass should always point tangent to that line, to that curve. So there are compasses that are not pointing as tangents. So D is rejected, B is rejected. And the direction of the field is always from north to south. So the compass that is pointing with the field is the correct one. So this is the correct one. So we choose C. Question 26 says a bar magnet can be demagnetized by hammering it for a long time or by slowly removing it from a coil connected to a power supply. Which row completes the descriptions of how these processes are carried out? So hammering the bar magnet for a long time with an east-west orientation or north-south. North-south takes the magnetic field direction of the Earth, so it will help the magnet get more magnetized, not demagnetized. So it is best to place it in an east-west direction. And slowly removing the bar magnet from a coil connected to a DC supply or an AC supply. An AC supply will demagnetize, a DC supply will magnetize an unmagnetized bar magnet or will make it stronger, so we choose B. Question 27 says, which particles move in a metal to cause an electric current? That would be electrons or the free electrons in the metal, so the answer is A. Question 28 says the diagrams represents 4 copper wires. Which wire has the greatest resistance? So for the greatest resistance, we have the longest length and the smallest cross-section area. So longest length, that's C or D. Smallest cross-section area, that is C. Question 29 says an air conditioning unit, a lamp, and an electric fire all receive electrical energy from the main supply. From which of these devices is all this energy eventually transferred to the surroundings? So eventually transferred to the surroundings, that's actually all the machines we use. So it would be all of them. So this is the row with all of them dissipating energy to the surroundings. So we choose A. Question 30 says 4 circuits are set up. In which circuit does the ammeter show the greatest reading? So all these are parallel connections with the same resistance and the same potential difference across the battery, or the same EMF. So we will just see which ones with the diodes working and not working. So if the current is moving this way, so this will work because it's pointing in the same direction as the current. This will work also. This will not work. This will work. This will not work. This will not work. This will work, this will not work. So the one with the most branches working will be with the greatest total current in the circuit, so we choose A. Question 31 says the diagram shows an electric circuit. The light falling on the light dependent resistor increases in brightness. What happens to the resistance of the LDR, the current in the fixed resistor, and the reading on the voltmeter? So for the increasing brightness, the resistance of the LDR decreases. And when the resistance decreases in a series connection, the current increases. And for a fixed resistor, the voltage is equal to current multiplied by the resistance, and the current increased, so the voltage will increase. So the common choice here is B. Question 32 says the diagram shows 2 linked circuits to control when a bell is switched on. The conditions are altered and only one pair of conditions causes the bell to ring. Which pair causes the bell to ring? So we need the switch to be attracted, which means the coil must get magnetized and the current here should be great. For a high current, we need low resistance, so the resistance of the LDR and the thermistor should be low. This happens when the brightness of light on the LDR is high and the temperature on the thermistor is also high. So bright light and high temperature, this is the choice. So the answer is A. Question 33 is about logic gates, so you can skip this question for the new syllabus. It says the truth table for a logic gate is shown. Which type of logic gate is it? So we have all the output is 0 except for when the input is 0 and 0. So this is the opposite of an OR gate. An OR gate would give an output 0 when both inputs are 0 and 1 whenever any of the inputs is 1. So this would be the opposite of an OR. It will be an OR gate. So the answer is B. Question 34 says, in this circuit, a component at X automatically protects the wiring from overheating if there is a fault. Which row indicates components that are suitable for protecting wires from overheating or from too much current passing? That would be a fuse or a circuit breaker, not a switch. So not a switch, it would be a circuit breaker, okay, and fuse is also okay. So the common choice here is B. Question 35 says the diagram shows a simple transformer with an input of 240 volts and an output of 40 volts. There are 600 turns on the primary coil. How many turns are there on the secondary coil? So we can use the relation NS over NP is equal to VS over VP. So NS is the required in the question, NP is 600 and VS is 40. VP is 240, then we do cross multiplication. 600 times 40, then divided by 240. That would give us an answer of 100 turns, so we choose A. Question 36 says the diagram shows a current carrying wire. The wire is at 90 degrees to the magnetic field. The direction of the magnetic field is into the page. A force acts on the wire due to the current and the magnetic field. In which direction does the force act? For this, we used Fleming's left-hand rule. So if the field is into the page, we point the index finger into the page, and the current is to the right, so the middle finger is to the right, and the thumb shows the force direction or the direction of the motion. So here the force is towards the top of the page, so it's not into the page, out of the page, towards the bottom, no, towards the top, yes. So the answer is D. Question 37 says a radioactive substance emits radiation at a rate of 600 emissions per second. 4 hours later, it emits radiation at a rate of 300 emissions per second, so the activity decreased by half. So the 4 hours is actually the half-life. What is the half-life of the substance? We already said it, 4 hours. And what is the rate of emission after a further 4 hours? So from 300 and another half-life passes, that would be 300 divided by 2, which is 150, and it's also never 0, so the answer here is D. Question 38 says the nucleoid notation for an isotope of silver is Ag109 and 47. How many nucleons are in the nucleus of the isotope? We use the nucleon number here, which is 109, so the answer is C. Question 39 says the equation represents an isotope of radium Ra decaying to an isotope of radon Rn with the emission of a particle X. What is particle X? So we can use the numbers here. 226 minus 222, that gives us 4, and 88 minus 86, that gives us 2. The particle with these numbers is the 1, so we have the helium 4 and 2, so we choose C. Question 40 says an atomic nucleus decays by one or more radioactive decay process. What causes the proton number to decrease by 1? So if we are emitting an alpha particle, that decreases the proton number by 2, not 1. But if there is an emission of a beta particle, that adds 1 proton to the nucleus, because 1 neutron changes into 1 proton. So if we emitted alpha and beta particles, 1 alpha and 1 beta, that would leave us with 1 less proton. So this is the one. So an alpha decay followed by a beta decay, yes. Not alpha decay only, not beta decay followed by gamma decay. Gamma decay does not change anything. Beta decay only increases the proton number by 1, not decreases by 1. So it is not D, it is A. So this was the end of the exam. I hope you enjoyed the video and found it useful. Keep practicing, and I will see you in another video.